Yesterday, starting chapter 11, we talked about parts of a circle. Okay, today, or throughout this whole chapter, we're still going to deal with those separate parts of a circle, but we're going to deal with them one at a time. Okay, so today we're going to deal with our tangent lines. Does anyone remember from yesterday what a tangent line is? How can you describe it?
It's a line on the outside of the circle that only touches it once.
Yep, there's a line on the outside of the circle. Most important part of that is that it touches one point. One point on that line touches the circle. Okay, so here it says AC is tangent to circle B. They name circles based off of their center. At point C, they say it's tangent of point C. What do we call that line? Or that point?
Point of tangency.
Point of tangency. Okay, it wants us to find BC. So I'm going to put an X there because that's what it wants us to find.
Oh, hold on a second.
What do you notice that it creates?
That's just the Pythagorean theorem.
Yes, that does give us the radius, but why do you say Pythagorean theorem?
Triangle. A squared plus B squared equals C squared.
Right, what triangle is it though?
Right.
Right. It creates a right triangle. Tangent lines should create a right triangle. Okay, so to find that missing side, we can use the Pythagorean theorem. What is the Pythagorean theorem?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. Now, we can't just start plugging in numbers. We have to plug them in the right spots. So, which two should I circle?
X squared plus 12 squared.
I should circle the legs. What are my legs? X and 12. So you know that your legs go together, so they are your A and your B. So we have X squared
Plus 12 squared.
plus 12 squared
Equals 13 squared.
equals 13 squared. So biggest part is making sure you plug them in the correct spots. Okay? So X squared stays. What's 12 squared? 144. What is 13 squared?
169.
169. Okay, we need to solve for X. What do I need to do first?
Minus it.
Yep, subtract 144.
From 169, that gives you 25.
So then we have X squared equals 25. What is always the last step of the Pythagorean theorem? We're going to take the square root. What is the square root of 25?
5.
X equals 5. Okay, so we just found our missing side. What is that missing side? What part of the part of the circle is that? It is the short leg of the triangle, but think of the circle.
It's radius.
It is the radius of the circle.
It's half the diameter.
Okay.
So the diameter would be 10, yeah.
Good. All right. Look at another one. I'm not going to go through that one. Skip to this problem here. Okay? We've been using the Pythagorean theorem for a long time now, so it should be no issue for you. On here says, how can we show that EF must be tangent to circle D? Okay? EF, does it look tangent?
Yeah.
Yes, but what did we say tangent lines create?
Right angle.
They create that right angle. So we need to be sure that this is true. Okay? So we're going to use the Pythagorean theorem to see if we come out with a true statement.
It has to be
So, Pythagorean theorem is what? Yes.
A squared plus B squared equals.
A squared plus B squared equals C squared.
So 9 squared plus 12 squared equals.
So, remember, we need to plug them in the right spots. What do I circle?
9 and 12.
Circle the legs. And remember, if they don't have that right angle in there, it's created by that tangent line. So, put it in there yourself. Okay? So, we circled our legs. We know those go together as our A and our B. So, we have 9 squared plus 12 squared equals, do I have a C this time?
15 squared.
Yes. When it has this line through here, that means that whole thing is 15. Okay. So now just evaluate, like you know how, what's 9 squared? 81. What's 12 squared? 144. And then 15 squared.
225.
It is 225. Okay. There's one more thing I need to do is what?
Add them together.
Right, I need to simplify both sides. This side is already simplified, so I need to simplify this side. What's 81 plus 144?
225.
It is 225. Equals 225.
It is alright.
Is that a true statement? Does 225 equal 225? Yes, so therefore, it is a tangent line. Okay. Its side lengths, those side lengths of the triangle, satisfy the Pythagorean theorem, so therefore it is a tangent line. What if I did not get a true statement here?
It wouldn't be
then it wouldn't be a tangent line. Okay? Questions on the Pythagorean theorem? We've been using it for a long time now. Okay. Questions about the Pythagorean theorem and applying it? Okay. We got one more thing to talk about, and that's the property of tangent lines. Right now, what do we know about tangent lines so far compared to circles? What do they create?
A right angle.
They create that right angle if we drew it in, okay? So right angles are created. We know they're right triangles, okay? If we have more than one tangent line like we do here, what do you think they are? How do you think they compare to each other?
It's like a pyramid.
They come to a point at the end, okay? So what do we think we know about their lengths? They're the same. When you have tangent lines that connect, their lengths are the same. What's the word for the same? Starts with the C. Congruent. Okay, so if they are congruent, how can we set this up to solve for x?
2x plus 3 equals 11.
Right, if they're congruent, that means they're the same. So if they're the same, we set them equal to each other. So 2x plus 3. So 2x plus 3 equals 11.
Minus 3.
Okay, so now we need to solve for x to get x by itself. First step is
Subtract 3 from 11.
subtract 3 to get
8.
x alone. And then what's its last step?
Divide by 2.
Divide by 2.
X equals 4.
Which is x equals 4. I don't need you to plug it in or anything. All I have to do is to get x by itself. Okay, so we learned two properties of tangent lines today. We learned that they create a right angle and that their lengths are congruent to each other. Okay, go ahead and try these two on your own. So there's some algebra going on today, okay, but you have spent a lot of time practicing that throughout the year. So on 1 and 2, what do we know about properties of tangent lines? They're congruent, which means they're the same. Whenever you say something's the same, what do?
Well, it's the same.
Set them equal. Okay, so I have x equals what?
15.
15, so do I have to do anything?
No, it's 5.
No.
Or 15.
Okay, x is already by itself. You don't have to do anything farther than that. Okay, so on number 2, what do we know about those two tangent lines? They're congruent, which means
5 equals 14.
they're the same, so we set them equal to each other. Take one, set it equal to the other. So now we have to solve for x.
Subtract 5 from 14. That gives you
Subtract
9.
5 first. So then we have 3x equals 9. And then we want to get x by itself. That last step is divide by 3. So we have x equals 3. Okay, take your time solving those. Go through all those steps. Okay? Questions about Pythagorean theorem or properties of tangent lines? Okay.